class I have. So if I don't record it, then oh well, we don't have it. Okay. And yesterday was pretty quick. I got both the I think got both the BC lesson and the math analysis lesson up yesterday. So we'll see how long that lasts, but with any luck. All right. So we need to find the intercepts. Okay. So this was something that we did do last year. We talked about it in math analysis last year. So to find intercepts, that's basically the same thing. The word intercepts is the same thing as zeros and the word roots. All of those words are interchangeable. And really actually what it's asking for, that's actually talking about an x-intercept. It also could be asking us for a y-intercept. No, I'm sorry. Yes, those are asking us for x-intercepts. It also could be asking us for a y-intercept. So basically what you do is you do the opposite. So to find a y-intercept, you put 0 in for x. To find an x-intercept, you put 0 in for y. So it's the opposite of which one you're trying to find. Okay? So I'm going to start with my y-intercept. I'm going to put 0 in for x. So 0 squared plus 0 minus 2. So what's the y-intercept? Negative. But I wouldn't write that as an intercept because guess what? That's a line. That's a horizontal line. An intercept is a point. So 0 comma something or something comma 0. Does that make sense? Yeah. So we're looking for a point. All right. On this one here, I'm going to plug in 0 for y. So we've got 0 equals x squared plus x minus 2. All right. I've got a quadratic. How do we solve a quadratic? Factor magic x. Perfect. Okay, now this is probably the last time I'm going to show you a magic x in here. You are in calculus. I should not need to factor for you, right? If you need factoring help, you need to come see me on your own time. All right? So, we've done this since, I know that I had my hands on you, a lot of you last year. We've done it since day 1 last year, or day 2 last year. Okay? So, two numbers that multiply to negative 2 and add to 1. Which one has to be negative? 1. Okay, so we got 0 equals x minus 1 times x plus 2. What property do we need? There we go. We remembered something. Good. Good job, Jordan. All right. Oh, thanks. It's because I beat it into you, right? Yeah, I told you the second day of school last year that the two things you were going to know was the leading coefficient and the zero product property, right? We still remember them. All right, what am I going to do with that 1? Move it to the other side. Move it to the other side. Sorry, we're going to add it to move it to the other side. Hang on. All right, and then what are we going to do with the 2? Subtract it. Now, technically, those are vertical lines, right? Mrs. Ballard would say that's not an intercept. An intercept is a point. So this time, where does the 0 go? In the x spot or the y spot? In the y spot, good. All right. So there's your x. And I would make sure you would label them y-intercept, x-intercept. Okay? I'm going to hit the air conditioning button. So this button over here on the wall, because it's early and the air doesn't come on probably yet, let me turn it on. That's the air conditioning button. Okay? I think I have the flu, or something. Because I've been going hot and cold and I've got the lovely, sore throat already. It's great for the first week of school. Yeah. Okay. Test for symmetry with respect to each axis and the origin. This is something where you had to watch the lesson, okay? Because remember there were the video lessons that were connected to this. So you either had to watch the lesson or you had to read it in the book, okay? So let me find it in the book here really quick and I'll give you a page number, okay? There's 2 of these things. There was a goofy one about symmetry and then there's one about evens and odds. These are the 2 that everybody misses all year. So we're going to let Mr. Lepis' class miss the problem and we're going to get it right. Okay? Does that sound good? All right. So this is it's a box on page 5 of your book. Okay? And I'm going to kind of write notes about the box and then we'll test them. Okay? So if it is y-axis symmetric. Okay? So y-axis. You sub in... You replace x with negative x, okay? And then it's always, the answer is you always yield an equivalent equation, okay? X-axis symmetry. So if on y-axis we replace x with negative x, how are we going to do, what are we going to do with the x-axis, do you think? Yep, so replace y with negative y. And then to get origin symmetry, you replace both. Replace x and y with negative x and negative y. So we have to test for all three types of symmetry. Okay? So let's start with the y-axis. It's kind of a pain and it seems long because we've got to do all of that work. Okay? So I'm going to start with plugging in negative x. So I'm plugging negative x in, right? The only thing I could do to make this any different was maybe move the negative over to the other side. Did I get the exact same equation? No. So is it y-axis symmetric? No. Okay, so y-axis doesn't work. Now I'm going to go with x-axis. So x-axis says we have to replace with negative y. So x times negative y equals 4. Again, I could maybe move the negative to the other side, right? Did I get the exact same equation? No. So it's not y or x-axis symmetric. I'm going to do my origin down here. All right, origin symmetry says I replace x. Oops, sorry. And I replace y. What's a negative times a negative? Did I get the exact same equation? Yes. Okay, I got the exact same equation. So is it origin symmetric? Yes. So it has origin symmetry. It just depends on how the question is asked. It might be multiple choice or multiple response and ask you which one of the following does works. That would be a great multiple response problem, right? Because more than one of them could be right. Okay. All right, we good with number 31? Yeah. We're going to try to practice that one a couple of times because I don't want to lower the standard and take it off the test just because you're going to get it wrong. I want you to get it right. Because the reason I put that on there, and I know we didn't super cover it in math analysis, because you should be able to open the book a little bit and learn a little bit on your own sometimes, right? Because guess what? When you go to college, the teacher's not going to do every single problem. You'd be lucky if they do any problems. And don't just talk about the theory. That's why you're taking this class. Okay, so we're going to do this again, right? The 35 was the same problem. So let's test it again. X-axis. So which one did we start with first? Did we start with y first? Yeah, y-axis, x-axis, and then the origin. And the way to remember it is it's opposite. Just like the intercepts, it's the opposite variable, right? So for x-axis or y-axis, we're going to plug in a negative x. Okay, about the only thing I could do to that is maybe square that negative, right? Did I get the exact same equation? No, so I am not y-axis symmetric. All right. X-axis says I plug in a negative y. So I've got x over x squared plus 1. Only thing I could do with the negative is maybe shift it, divide it to the other side, right? Is there any way to get the exact same equation? No, so this one's a no. Origin says I replace both, right? So I'm going to put in a negative y and a negative x. Okay, I know my denominator, I get positive x squared plus 1. Could I divide that to the other side? So that's going to be a negative times a negative, which is going to go what? Positive. Did I get the exact same equation? I don't know why I happened to pick two that were both origin symmetry. Is it possible I give you an x-axis or a y-axis symmetry on the test? Yeah, so you need to be prepared for all of them. Hopefully it appears when you're going through the three, right? If it was me, you might even want to go through, there's a couple other in that section, maybe go through those couple other just to make sure you know what you're doing, okay? All right, we good with 35? Yeah. All right. Use a graphing utility to graph the equation, identify any intercepts, and test for symmetry. I think that's why I had you grab your calculators today, because I saw those, but now that I'm reading the question, we don't need that in order to get intercepts and symmetry, okay? So this makes this problem really long, okay? Because we got to test x-intercept, y-intercept, and the 3 symmetry tests, okay? So, on the test, am I likely going to have you do all of that on one problem? No, I'm going to take that one problem and split it into 2 or 3 problems, right? So, what? I'm not that mean to split it into 2 or 3 or make you do all that in one. No, I probably wouldn't, because it's too hard to grade, right? It's laziness on my part. Okay, you're lucky I have laziness sometimes, right? Okay, so let's start with our intercept. So I'm going to go x-intercept, y-intercept. So for the x-intercept, what do we have to do? What do I put in for y? 0. Okay, so we're going to put 0 in for y. So let's see, I've got negative x equals 9, so x equals negative 9. What does that make the intercept? Negative 9, 0. And remember, multiple choice, I'm going to probably try to confuse you. I might just ask you to find the x-intercepts, and then I might put a 0, 9 and a 9, 0. Okay, to confuse you to see if you know if it's really an x-intercept versus a y-intercept. Okay, so watch for those little catches. For the y-intercept, what do we do? Replace x with 0. Good. So we've got y squared minus 0 equals 9. Y squared equals 9. So what does y equal? How many answers should I have if it's squared? 2. So what does y really equal? There you go. Because remember, we took a square root, and we take a square root, we do a plus minus. Okay? So I actually have 2 intercepts. Do I have to write them separately? I could do that, and that's okay. All right, have we finished the problem yet? No. Always make sure you go back and read and make sure you've done everything. On this little test, I'd likely split it up. On the AP test, where they have a free response question, you're going to have multiple parts, and you're going to have, in each little part, there might be 2 or 3 things you need to find, okay? All right, so test for symmetry, I'm going to start with the y-axis symmetry. So y-axis, I plug in what? Negative x is what I'm putting in, right? Okay, so I'm plugging in y squared minus negative x equals 9. What's going to happen with the negative? Cancel. Did I get the exact same equation? No. Okay, so y-axis doesn't work. X-axis. What do I do to find x-axis symmetry? Put in negative y. Oops. Okay. So I've got negative y squared minus x equals 9. What's negative y squared? Y squared minus x equals 9. Okay. Did I get the exact same equation? Yeah. I did. So does it have y x-axis symmetry? Yes, this time it does. That's the first time we've seen that. Okay, now we want origin symmetry. So that I plug in negative x and negative y. So let's see, negative y squared minus negative x equals 9. The y squared is going to go positive. That's going to go positive, right? Did I get the exact same equation? No. No. So the only asymmetry it has is x-axis. Is it possible for it to have all 3? Yes. It's possible, or just 2 of them, okay? Or just 1 of them. Is it possible to have none of them? Yeah. Absolutely, it's possible to have none of them. Think about this graph, right? That's not, it doesn't have, well, I guess it could have symmetry, right? Maybe across the x-axis, but if I shifted it somehow, it might not, okay? All right, let's look at this one. Find the points of intersection of the graph of the equations. That's a fancy way of saying solve a, remember systems of equations? That's all that is a systems of equations. So, for systems of equations, we had 3 or 4 ways we solved it. We could graph them. That would be kind of a pain, okay? We could do substitution, we could do elimination, we could do Kramer's rule. What's your pleasure? It's set up nicely for elimination, right? So we got x plus 2x is what? 3x. The y's go away. What's 1 plus 2? Oh, how nice is this one? What's your answer to x? 1. All right, I'm not done yet. I got to find y. You want a lot of those on the test? All right, I got to find y. Am I going to plug into the x or the y? I'm sorry, the first one or the second one? First one. All right, so I'm going to put 1 in for x plus y equals 2. So what's y equal to? 1. How do I write the point? 1, 1. Okay, I can't leave it x equals y equals. All right. There's a couple of things that sometimes happen multiple choice. If I just give you the point, could you plug them in? Yeah, I don't like to do that because then all you do is plug them in and it doesn't force you to solve the system. On this one, because y was the one that canceled, I would have likely asked you just what the y value was from the system. Okay? Yeah, make sure you make it onto the seating chart if you walked in a little late. Okay? That's how I'll take rolls, whoever wrote their name on the seating chart today, okay? They don't yell at you for 0 period attendance being late, so, because nobody else is here. All right. It says use the graphing utility to find the points of intersection. Check your results analytically. Okay. I'm not worried about doing analytically. Let's put this one on the calculator. Okay. So I'm going to find this one myself here. Page 9, number 69. Okay, so everybody start typing those two functions in. Do we remember how to do that? Good. All right. Oh boy, let's see. Let me find. And remember, I didn't log you in yet because I just didn't quite get there. Okay, so we're going to go to our little... So we're going to your scratch pad in the graph. We've got x cubed. So there are a few things you have to be able to do on the calculator on the AP test. And finding a point of intersection is one of them. So that's why we're going to possibly put this on here. Make sure you grab the same calculator number as your Chromebook, okay? X squared plus x minus 1. Everybody in here used one of these last year, right? Okay. So there's one of them. Oh, I remember what goes on with this problem. There's something tricky. And remember, if that label gets in your way, you can just drag it off, okay? I know it's easier for me to do than you to do, but you either click or you hit tab, and that gets you the second one. It was negative x squared. Negative x squared. These ones are nicer than the old 84s because you can either put a negative or a minus sign and the calculator figures it out. Plus 3x minus 1. All right. We could, if we were going to do this analytically, which means using algebra accept, we would set the two equations equal to each other. That one was pretty messy to do that with, so I would probably have you do it on the calculator on the test. So I'm showing you how I would expect it done on the test. Okay? How many times do they cross? It's actually 3 times, and sometimes you have to be careful depending upon your window. You might have to move this up to see that third time. Okay, and it might be that way on the test where it looks like this. You need to look for that hidden point. Okay, and remember you can pull this to zoom if you need to zoom a little bit. All right, so let's talk about how do we calculate that. We go to menu. Do we remember? Because I think we did this last year. Analyze graph is kind of the key to finding things. All right, and we're looking for points of intersection, so what am I going to choose? Intersection. And then it doesn't really matter if you're to the left or the right. It wants lower bound, so technically left, until I hit one. See how it came up with one? Oh, look at that. Aren't we glad we didn't do this by hand? Look at those decimal points. Yeah, unless it was clean, I would not make you do it by hand. All right? If it's got ugly decimals, I expect ugly decimals. Do we know how many decimal points we do? We write down? 3. Did you read the summer work? Do we do any more rounding? No. We just cut it off. So you'd write down negative 1.31. Okay? And then negative 1.140. We do have to be careful that we only do that truncating piece at the end of the problem. At the middle of the problem, if we have to use the number somewhere, you want to use as many decimal points as it will give you. Remember how last year is driving you crazy, the calculator set and float 6? That's why, because we need all those decimal points to get an accurate answer, okay, in calc. All right, I'm going to do it again. Menu, analyze graph, intersection. There's my next one. Write 3 decimal places down, cut it off, so 0.066 and negative 0.942. All right, and then menu, analyze graph, intersection. I've got 1.995 and 0.975. Yep, those 3 points. That's all you're going to do on this one. Could you maybe sketch the graph? That would show me you did work, right? But again, these are hints. I'm not collecting this. On the AP, or no, sorry, on the actual test, am I expecting to see work on this one?
Yeah. No.
No. You're using the graphing calculator to do all the work. Okay? All right. We good with that problem? Let me just do this. Control, my favorite thing, Control J. Yeah.
Does the graph have to be like zoomed out? Because
No.
it's giving us the points. It's always giving us like 1.1.2 or something.
It's giving you what?
It's giving us like the actual points, not the decimal.
It's not giving you the decimals. Did you type it in right? Is everybody else getting the decimals?
I didn't get it.
No? Did I type it in wrong? Maybe I typed it in wrong. Check mine. It was problem 69, right? Cubed minus 2x squared plus x minus 1. That one looks good. Oh, what happened there? Look at that. That's what it was not. Maybe it was nice. Maybe mine is messed up. Let's see. Negative x. I must have grabbed a graph accidentally. I'm sorry. You guys, if I get it wrong, you have to let me know. So thank you for speaking up, okay? There we go. Were they nice now? But it was good that we had the decimal discussion anyways. All right, so write down the nice points. I apologize. I must have accidentally, when I grabbed it to zoom, I must have grabbed a graph and moved it. Yeah, I know. Welcome to zero period. You'll see more mistakes in here than any other class that I teach. Yeah. No. No. And I would probably keep it on 6 or 7. Okay? And math analysis, when they start using, they'll figure it. They might change it back. But you guys actually have the advantage. BC is kind of the class that's in before you because they're in the afternoon, so they may change it back to 6. But for our purposes in here, it's better to be the float to be higher. Okay? So we get a more accurate answer. Okay. All right. Are we good with 69 now? Yeah. Okay. Let's see. Oh, 69 page. I apparently put that one in there twice. I don't know why. That's why I probably went. We didn't. 70 wasn't part of it, right? No. A few of these I was grabbing really fast, so I grabbed 2 problems instead of 1. All right. You notice on the hints list that one had a star. That 69 had a star by it. That was because it was probably a calculator problem. Okay. So that's probably what the star meant. Okay. So this one is just number 9, not number 10. Is that right? Yeah, just number 9. Okay. Plot the pair of points, find the slope of the line passing through them. Okay, I don't know why they really need you to plot to find the slope, but we'll plot 1, 2, 3, 1, 2, 3, 4. 5, 1, 2. There's the plot of the points. There's 2 ways I could do this. If I plotted accurately, could I do a slope triangle and count the slope, count the rise and the run? That might, but if I didn't plot accurately, is that going to work? No. So the better thing to do is remember, use your slope formula. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Does it matter what x and y subs are? Just pick whatever point you pick to go first, make sure it stays first. So what am I going to put in for my first y? Okay, you want to do -4, that's fine, which means what does the first x have to be? 3 minus, what's the next y going to be? 2 and 5. Could I have done it in the reverse order? As long as I kept the pair together, right? On top of each other. So let's see, we've got -4 and -2 is -6 over So what's the slope of that line? You guys, that was a slope question. Should we get that one wrong? No, please don't get that one wrong. Okay? A slope question on your first calculus test, let's not get it wrong. Okay? I told you most of the year is going to be about slope though, right? So it's important that you know how to calculate that. Okay. Looking at this one, find an equation of the line that passes through the point and has an indicated slope. Sketch the line. It says the slope is undefined. What kind of a line am I drawing if the slope is undefined? All lines are straight, guys. Okay. Definition of a line is it has to be straight. I love that you did that though. It has to be either horizontal or vertical. A vertical line is undefined. Okay. A horizontal line has a slope that equals 0. Okay. So a vertical line is going to always go through the x value. A horizontal line is going to go through the y value. Okay. So to sketch it, I would do -1 and I would draw the line through -1. I haven't written, though, the first thing it wanted me to do is find an equation. So to do vertical lines, you literally do whatever that number is and x equals. Because that was what x equaled, right? If I was talking about the horizontal line, what would the horizontal line be? Y equals 2. Okay? Technically, both are fair game. My guess is it's probably that question, more similar to that question. But you should know the difference in how to write a horizontal and a vertical. All right, we good with 28? Okay. 32, same instruction. So this is more like the warm-up, right? Find an equation. I'm not really worried about you sketching it. We'll practice the sketch on this one, but I'm not sure I'll actually put the sketch on the test. So you got to go point slope. So y minus what value? What's the y value? 4 equals, what's the slope? -3/5 x minus -2. You guys, once we hit chapter 2, you won't go a day probably without using that equation, okay? This is something that when we're going to talk a lot about equations of tangent lines. Please don't ask us the day before the test how to write equation of a tangent line. You're going to use point slope, okay? So that's going to go positive. The only reason I would probably go to slope intercept is because they're asking me to do what? Sketch it, okay? I can't sketch it from here. Although I could. Let's try it. Watch this. -2, because we're all about being lazy, right? We are teenagers. So there's a point. Couldn't I count the slope off of that point? And then I don't have to do all this work of distributing. And that's even better. Okay, so I'm going to count down 3. 1, 2, 3, and over 5, right? Didn't say we had to plot it with the y-intercept and the slope, right? Double check, make sure you have a slope that looks negative, right? What? It could work with anything that's like that, yeah. Why not take the shortcut, right? Okay. Find the equation of the line that passes through the points and sketch the line. Could I just plot those 2 points and sketch the line? I don't have to follow the instructions in the order they gave them to me, right? So I'm going to plot those 2 points. So I've got 5, 1, and 5, 8. 3, 4, 5, 6, 7, 8. We're doing sloppy graphs. In fact, it was almost better that I sketched it first. What is the, what kind of a line is it? Vertical, so what's its slope? Slope is undefined, so I'm going to use the equation for that line would be x equals whatever the x value is, which is... What if these were different? It came out something like that. What would you have to calculate first? Wouldn't I have to do the slope formula? So if that was like a 4, I would do the slope formula first, and then I would put it into point slope if they asked me for the equation. Okay? All right. Looking at this one, it's not both of those. It was just 59. So write an equation of a line through the point parallel to the given line and perpendicular to the given line. What do we know about parallel lines?
They're straight. They're equal.
All lines are straight.
They're equal.
What part of it is equal? It has the same slope. Okay? Perpendicular. So let's not get this one wrong, because this I'm guaranteeing is on the test. Okay? So parallel is same slope. Perpendicular is the slope is the negative reciprocal. Negative reciprocal. Okay, so the first thing I need to do is figure out what on earth the slope of this line is, because that's where I'm going to get the slope from. Because to write the equation, you need two things, point and slope, right? So I got to get the slope out of this line. So that means I do need to go y equals mx plus b. So negative 2y equals, what am I do with the 4? Plus 3. What am I going to do with that negative 2? Divide it. So negative 4 divided by negative 2 is 2x. Do I really care about this piece right here? No, I don't even need to do it. If I'm saving myself time, I don't need that part. All I'm really concerned about is the slope. So for part A, which was the parallel, the slope would be 2, same slope. All I'm going to do is y minus y1, which is 1, times what's the slope? 2 times x minus what? What's the x value? 2. Part B is perpendicular, so what do we do for the slope on perpendicular if the original slope is 2? Technically it's 2 over 1, so when I flip it, what do I get? 1 over 2, but I also have to add what? Negative. Okay, I'm going to literally just do the same equation, pluck that out, and put in a 1/2. So y minus 1 equals negative 1/2 times x minus 2. Notice we've used that point slope formula at least 3 or 4 times already, right? It's important that you know that. It's going to be all over this test. Okay. We're still doing good. Okay. We good with that number 59? Okay, I don't want to go too fast and make sure you don't get something right. Okay, this one's weird. Okay, determine whether the points are collinear. What does collinear mean? They're on the same line. You'll notice that calculus is where we bring algebra and geometry together. Okay, because the last time you saw collinear was when you took geometry. Okay, we do a little bit of both and then we add the calculus part to it. Okay, so this means we're, oh, duh, look at it, told you right here that they are on the same line. To be on the same line, they have to have the same what? So what we're calculating is the same slope. So I need to test in between all 3 pairs to make sure the slope is the same. As soon as 2 slopes aren't the same, they are not collinear. Okay? So I'm going to test this first slope. We've got, what, 0 minus 1 over negative 1 minus negative 2. Everybody okay with that? That first 2 points? All right, double negative is going to go what? Positive. So I've got negative 1 over 1, so negative 1. All right, my second pair, so I'm going to do this pair here. What? Negative 2 minus 0 over 2 minus negative 1. Double negative, positive again. Negative 2 over 2, which is? Oh, negative 2 over 3. Did it work? No. So are they collinear? Not collinear. Now, if it did work, I have to see how there's a third hidden pair there. You have to test that third pair. Okay, let's just do it just to show it so we know in our homework when we're looking at this to study that we've got to maybe do it. Negative 2 minus 1 over 2 minus negative 2. So negative 3 over, so definitely not collinear, right? Because all the slopes are different. All right. Okay, page 18, number 84. That one. Find the equation tangent line to the circle. All right. you did circles back in geometry. Okay. We didn't do them. We didn't do any of the what we call the conic sections last year in math analysis. That was the part we dumped off at the end of the year. Okay, because it's not vital to calculus. If you look right up there, you guys see this poster up here that says conic sections? See the one that says circle? Okay. Remember how we go in and out of parentheses? We talked about that last year. That gives us a vertex. In a circle, it's going to give us what we call the center. So what would my center of that circle be? What are the values? 1, 1. But so remember, in and out of parentheses, we always flip the sign. Okay? Now, look at that formula again. It says that it equals r squared. So what is this thing here standing for? What's r in a circle? Radius. So the radius of the circle, I'm going to write out the radius, it's r, okay, is the square root of 25, which is 5. Okay? A tangent line, okay, so if we go back to geometry, okay, we've got our center at 1, 1. We've got our radius 1, 2, 3, 4, 5. 3, 4, 5. I probably won't draw a perfect circle. 2, 3, 4, 5. 2, 3, 4, 5. Okay, so there's my circle. There is a circle property in geometry that says the radius and its tangent line are what? What is that spell? When it's 90 degrees, what do we call that? Keep going. Perpendicular. Okay? So, the radius and the tangent line are perpendicular. So that's the key to this problem, is knowing that your tangent is perpendicular. Okay? It wants me to find the equation of this line right here. Okay? So the point on the line, and I don't know that I drew it in the right place, is 4, 3. Okay? We know that this point is 1, 1. Could I get the slope of that? Could I get the slope between these two? Yeah. Okay, so let's start by calculating the slope of that point. So what are my y values? 1 minus what? 3. What are your x values?
1
minus 4. So we got negative 2 over negative 3, which is just going to go positive. In order to do the tangent line, I need the perpendicular slope. We talked about that a few minutes ago. What's the perpendicular slope going to be? Reciprocal and change the sign. Good. Okay. All right. What? Calculus is the study of slope. Okay, that's Mrs. Ballard's definition, but that's basically what we do all year. The answer to the question I ask you on the morning of the AP test is slope. Okay, so we go out and take a picture, and to get you to your instead of saying cheese, I ask you a question. Okay, all right. Equation of the line. We're going to use this point and this slope. So what's your y value in the line? Just 3? Oh, I screwed up, didn't I? That point is definitely not in the right spot, is it? It's this point. What's my point? Negative 3 equals, what's the slope? Negative 3 over 2, x minus, what's your y value? I'm sorry, x value. 4. If you wanted to turn that positive, if not, I'll take it the way you got it. Okay. Okay, let's see what the next one's about. Oh, we're going to save that for tomorrow. Okay, so I'm going to stop there. All right, we need to get remember you have to log out and shut down the Chromebook. I know we did use the calculators today, didn't we? Put the calculators away, put the Chromebooks away. Okay, once you've done that, you can go ahead and go. If you are one of the people who's new, I need to see your summer work, just so I make sure I get a grade. If you have the syllabus, I'll take it. I know I don't have a basket up there yet. Okay. Yep, give me just a second. Let me find the right clipboard here. So I was at least writing it down.
Wait.
Summer work, not the hints, the summer work.
Oh.
Okay? Thank you. Yes. Syllabus, yes. Gonzalo, you need this too. Oh, you have it already, right? That was this
I
week's
think
homework.
I already have that, except it's in a different format.
I don't have that.
You don't have this?
No.
Okay.
Can I get the syllabus?
The syllabus, yeah. Okay. And then that's this week's homework. It's also online. Okay, we're doing everything digital. It's the last time I'm giving you a worksheet, okay?
And then rest of mine.
Yep. Let me just flip through it for you. Thank you, Savannah.
Miss Valerie, do we need a separate binder for this class?
All I need is the spiral notebook. Okay, give me a second, okay? I'm doing
Oh,
this.
I got to staple my unit 13.
5, 6, 7. So I don't see 8.
Was there 10?
There were 10. I only saw up to 7 there.
This is from all last year.
Gonzalo, you can bring it back here. She was doing summer work too. Bye.
Oh, well, this is 9 and 10.
9 and 10, so you're just missing 1. Okay, so you can still get that to me. Okay?
Change my seat.
I know I did. I'll find it.
Huh?
Can I change my seat?
Yes, you may change your seat. Let's see. So I'm gonna go 450 for you right now. Okay, but I can edit that. Oh, you're not in here yet, Cordero. Okay.
Summer work was hard.
Well, we're going over. You want to make sure you know how to do these problems, right?
Yeah.
So that was 6.
1 through 6.
Okay. So you got 8 done, so 400. If you finish it, I can still give you points, okay?
By what?
If you could get it by Monday, that would be awesome. Okay?
They'll figure it out. Yeah. It's their problem. You just saved 2 minutes.
Don't forget to remind me, I have to show you the number 5 assignment. I haven't done that yet, and I have it up there. Okay, let's look at number 27. Okay? You guys, this is not a hard problem, and this is another one where people make a bunch of mistakes on it, but you guys have, I mean, this is way more important than that symmetric stuff we were working on yesterday. Okay? You have to be able to understand how you're reading things off of a graph. Okay? So that's why I handed out the little graph patch to you, so you can scribble on it and see very clearly and touch it, right? Sometimes it helps to touch it. So first of all, we just have to identify the domain and the range. So A was domain and range, and this is going to be, I'm going to do of F, of G, domain, and range. This is, remember where we use the brackets and the parentheses in interval notation? What?
Is it like infinity?
Well, do I have arrows on the ends of this one? No. So are there any infinities? No. Okay, so let's think about it. So is domain the x's or the y's? X. Remember, it goes alphabetical order. So domain is going to be starting where for the f function? -4, and where is it going to end? 4. Another thing to always watch, and the book will sometimes do this to us, is watch your scale. This one is scaled in 1s, but sometimes they'll scale in 2s in this book. All right, range is the y's, so I'm going to look at the y's. So where do the y's start on this line here? -3, and where does it end? 5. Excellent. All right. Then the domain and the range on G. So I'm going to start with my x's. So where is G starting on this?
-3.
I'm like in -3. Okay, and where is it ending on this? 3. Perfect. Okay. The range is starting where? -4. And where is it ending? 4. Good. I'm going to erase my scribbles on my picture because it gets to be too much sometimes. Okay. So we got the domain and range out. And it's a long problem. Probably I would split this into a couple and say, hey, refer to this picture. Okay. It says identify f of -2 and g of 3. This in here is an x value when it's on the inside. So they're asking us to go to this x value and find y. Does that make sense? So we're going to look at that x value and find y. So we're on B, and I'm doing f of -2 and f of 3, or g of 3, sorry. There's no written work. I'm reading it all off of the graph. So this is your interpreting the graph skills here. Okay? All right, so I'm going to -2 on the x value. So 1, 2, I'm going to the f graph. What would we say the y value is? Negative. Do you see how I drew on it? I went to -2, I drew down to the graph I needed, and I drew over on my y to read my y value. So use the picture, okay? All right, g of 3. So I'm going 1, 2, 3. I'm going to go down to my g graph. What's the value at g of 3? -4. All right, again, I'm going to erase on my graph so it doesn't get too icky. All right. The next question is asking, where are they equal? So they're talking about points of intersection. So there's only one place. So what's this point? Oh, so no, wait. For what values of what? X. Do I need the y?
No.
No. So we only need x equals. What's the x value where they intersect? -1. Perfect. Okay. All right. Now this is the one where people like get it messed up. So let's think about this. It's f of x. Think about it this way. Equals a y value. So the x goes there, the y goes here. So what value are they giving you? The y value. What do you need to find? The x value. Okay? So in this one, D, f of x equals 2. We need to find x. So I'm going to go to the y, where the y is 2, 1, 2. Which graph do I want to read off of? The f graph or the g graph? F graph, and I'm going to go down and grab the x value, which is 1. Okay? And then for E, we've got g of x equals 0. So we're going to go to where the g graph is equal, or to go to where the y value is equal to what? 0. And then which graph do I want, the f or the g? G. And so what am I going to read? -1. You need to practice it. There is a number 2, okay? You might want to try the number 2 as well. And then again, this is the thing. Shut the book, right? Go back to the question, or shut the work that you have. Go back to the question and try it again, and then double check to make sure you did it right. This one, super easy, right? But if you don't know what you're doing and you don't practice it a couple times, you mix up the x and y thing a lot. That's especially these ones down here are the ones people miss, okay? All right, looking at number 28, we need to evaluate the function as indicated. It's remember, piecewise. It's a piecewise function. This means if it's less than 5, we go into the top branch. If the value is or less than or equal to 5, we go in the top branch. If it's greater than 5, we go into the bottom branch. It's going to disappear on me for a second here. Okay, so in A, I'm looking for f of -3. So do I go into the top branch or the bottom branch? Is -3 less than 5 or greater than 5? Less than 5, so we go into the top, so I'm plugging -3 in. So what's -3 plus 4? 1. Square root of 1 is? 1. All right. F of 0, top branch or bottom branch? Top branch. 0 plus 4 is? 4. Square root of 4 is? 2. All right, this one's trickier. Top branch or bottom branch? Top. Why? Less than or equal to. Okay. All right, so 5 plus 4 equals what? They were nice to us, weren't they? 3? All right. Part D. F of 10, top branch or bottom branch? Bottom, because it is greater than 5. So we've got 10 minus 5 squared. What's 10 minus 5? 5 squared is? 25. All right, we good with 28? Okay. Let's keep going. All right. 58. Same idea. We've got some composition going on here, though. So remember with composition, and composition's important that you understand the concept of putting a function inside of a function in here. That's why I assigned this one. I'm making sure we can do it on the test. You follow the instructions. These are all instructions. So this is telling us take this back thing and sub it into which function? G. And then once I get the answer, I'm going to sub it into F. And it's something that's important, but we spend like 2 days on it, right? And we're done with it. And we take the test and we move on. So, but you gotta know composition. All right, so I'm going to start by I'm going to do G of 2 first, which is, I'm going to put 2 into here. So pi times 2, or what, 2 pi? Where am I going to plug the 2 pi into now? F. So the proper way to write it would be F of G of 2. So you're really taking the F function, which is sine of the 2 pi is what we're subbing into it. Can I evaluate that? Because it does want me to notice. Evaluate the expression. So what is the sine of 2 pi? 0, right? Remember, it's cosine, comma sine. Remember, what's happening tomorrow? Unit circle pop quiz if Mrs. Ballard doesn't forget to copy it, right? Yeah, if I forget to... Well, I guess I could print it. You're a pretty small class. Okay. So make sure you've got it. You've got that. Remember, you have to have the circle memorized plus answer 20 problems, right? And am I grading the circle? No, I'm not grading the circle. Yeah.
How long do we have?
10 minutes. Okay. You can do it. You guys, do you need to write out all the radian measures? No, if you wrote in just the 1, 2, 3s, right, really quick, do you need to write in the over 2 part? No, they're all over 2, right? If you write in the 1, 2, 3s, that'll take you about 10 seconds, okay? And you can kind of count off the radian measures. If hopefully you at least kind of know where those are, you're going to probably do pretty well, okay? We'll see. Usually the first round, about 4 or 5 usually get 100, and then after that we usually have a lot more. So if you can beat 4 or 5 getting 100, that's awesome. All right. This is saying I'm plugging 1/2 into where? G. Okay, so I've got G of 1/2. That's a G, believe it or not. So I have what? 1/2 pi. And now where am I plugging that into? F. So F of G of 1/2. My F function is sine. And I'm going to rewrite that instead of 1/2 pi as sine of pi over 2, which is up here. What's sine of pi over 2? 1. All right, C says I'm going to take 0 and plug it into where first? F. So F of 0 is sine of 0, which is what? 0. Okay, good. And now I need to do G of F of 0. So what function are we plugging the 0 into now? The G function, right? Because that's what's in front. So we've got pi times 0, which is 0. Good. All right, D. I'm plugging pi over 4 into what first? F. So F of pi over 4. Let's see. So sine of pi over 4. That's one that was easy, right? What are all the over 4s? Square root of 2 over 2. You just have to watch your sign, right? So and I would probably also write down all students take calculus just to remind yourself of the signs. All right, so I need square root of 2 over 2. I'm now taking that and plugging it into what? G. So G of F of pi over 4. So it's pi times square root of 2. Do I have to rewrite it? I don't. Either one of those is fine. It looks weird, but that's correct. Okay. Now what are they wanting me to plug in? X. Isn't it already X? It's pi x, isn't it? So we're taking this whole thing, that function, and plugging it into f. So I'm just going to write f of g of x I'm going to write my f function, which is sine. Remember, this is where we leave the blank, and I plug into this. So I plug my other function into it, sine of pi x. Could I leave it like that? Could I evaluate? Oh, look at this. I think I can keep going. Negative 1, 0. What's the sine of pi? Oh, but wait, it says pi x. Never mind, leave it. Yeah, leave it. Leave it in x. Because we don't know what x is, because if x was 2, then it would be over here, wouldn't it? Yeah, so I would just leave it. All right, f. What am I plugging into what this time? F into g. So g of f of x equals, I'm taking the, I'm going to write the g function, leave parentheses for the variable, and put in sine x. I really don't need to rewrite it. I can just leave it like that. Okay? Okay. You good with 58? You can handle a few of those? Okay, I guarantee that's going to work. Okay. Let's take a look at the next one. Okay, here's the other graph one, right? So get your little graph paper out. Ruben, hand this up to Dustin. Okay. I love this problem. What does that mean? No. Where will you see it? On the test, okay? So if Mrs. Ballard likes it, it's going to be there, okay? What? Am I already preparing you? Always. These are the skills we need just to do calculus, right? These are the algebra skills we need to do calculus, and then we'll start next Tuesday. We'll start on calculus, okay? What? No, you're going to go for a 3, dude. Okay? Look at, I've only got 19 of you this year in AB. We should be able to do this, right? Okay. That's right. And then those of you that are sophomores, or sorry, not sophomores. I'm used to you being sophomores. Juniors, right? I get to see you again next year, right? We get to do this again. All right. Hey, I've got what? Anna Chavez, I've had all 4. She's in BC this year. So, Robert Connor last year, I had all 4. Because they started as freshmen in Algebra 2. So, and then they did the math. They did it in the right order. They didn't do any skipping. So, all right. So what this is saying is I'm going to take 3 and plug it into G. Okay, but I have to read it off the graph. So remember how we did the reading off the graph problem the last time? Is this an X value or a Y value? No. X, and I want to read the Y because the 3 is in parentheses, so I'm reading the Y. So first thing I'm going to find for A is G of 3. Okay? So G of 3, I'm going to go out 1, 2, 3. I'm going to go down to the G graph. What am I reading for the Y value? Negative. I see 1. Do we all agree with the 1? Yeah. Okay. All right, now I need to find f of g of 3, which means I'm going, what am I going to look for my x value? I'm going to go to negative 1, and which graph am I going to go to? F. So I'm going to go to negative 1, I'm going to go to f. What am I going to read for that y value? 4. Good. And this is another one, you guys. Practice this exact problem a couple of times, okay? Because I don't want to see you mess this up on the test. Once you get the hang of it, it's not difficult. But you got to be able to read off the graph. That's a big thing in here because we do it all kinds of different ways. You don't know how they're going to present your information on the AP test. All right, where am I going to read first? 2 into f. Okay, so I'm going to find f of 2 first. I'm going to 2 on the x. I'm going to go to my f graph, which is right there. Where does it you think it is? 1. And remember, you have the little piece of paper. Okay, so if you need to look at it more carefully on there, that's a good thing. All right, then you've got g of f of 2. So what am I really plugging into this? The 1 is going into g. So I'm going to go to 1, and I'm going to go to my g graph, and what would we agree on there? Negative 2. So my final answer is these two things here. All right, C says we have g of f of 5. Let me erase my scribbles. Okay. So I'm taking the 5. Oh, I should have done this. I didn't do my f of 5, right? There we go. G of f of 5. Okay, I'm taking 5 and I'm putting it into f. So I'm going to go out 1, 2, 3, 4, 5. I'm going to go touch my f graph. What do I get? Negative 5. I'm going to take that and plug it into what? G. So 1, 2, 3, 4, 5. Ooh. Does it touch anything?
Would that be undefined?
You could write undefined. There's another one we use in calculus. It's DNE, does not exist. Either one is fine. Okay. I'll take either one.
But could that be like an infinity, or because it doesn't rely on that?
Sometimes infinity does not exist, but no, there's no infinity because there aren't any arrows on the graph. Okay. All right. D. F of G of negative 3. I want to find G of negative 3 first, though, right? Sorry, I scribbled on top of the graph, didn't I? All right. We're going to go to our x value of negative 3. 1, 2, 3, and I'm going to go to my G graph. What would we agree on for that answer? Probably negative 2. Okay? And then I'm going to go take that negative 2 and look at which graph? F. So negative 2, and we're going to go to the F graph. What do we end up with? 3 sounds good to me. Okay? All right. E. I'm going to start by finding F of negative 1, and then we're going to find G of F of negative 1. All right. So, negative 1 is here, and I'm going to go to which graph? F. What would we agree the number is? 4. Okay, and now I'm going to take that 4 and go to which graph? G. So 1, 2, 3, 4, go to G. What would we agree that is? 2. All right, F of G of negative 1. And of course, I forgot to write my G of negative 1. Okay. So G of negative 1 is here. I'm going to go to my G graph, which is down. What would we agree that number is? Negative 4. I'm going to go to negative 4. 1, 2, 3, 4. And I'm going to go to my F graph. What do we notice? Undefined or does not exist are both acceptable answers. All right, we go with 63. All right. We need to determine if the function is even, odd, or neither. This is another weird one. You had to kind of look it up in the book or made sure you watched the lesson. I'm going to look up the page for the problem, or the box again. It's on page 26 in your book. So go to your book, page 26. Okay. So a function is even. This is basically a summary of the box. If f of negative x equals f of x, the original. It's odd if when you put in a negative x, you get negative f of x. So the negative of the function. If we were looking at it with the calculator, remember odd functions look like this, right? Even functions look more like that. But even functions could also maybe be circular too. So you gotta, it just depends. Like actually, something circular isn't a function. So, all right. So what am I supposed? What's the key to plugging in? What do I have to put into this? What does it say? Negative x. I'm going to put in negative x. So we've got negative x squared, 4 minus negative x squared. Well, look at that carefully. Look at what I did. Oh. That should be like that, right? I messed it up even. Notice how I plugged the negative into the squared functions there. So what happens to the negative when we square it? Goes positive. For this negative stays, but that negative goes away with the squared. So look at the functions. Did I end up with the exact same function? Yes. So which one is it? Even. Guess what? If it could also be neither one of these, so it could be neither. Okay, even or odd. And again, that was something that we if we touched on it in math analysis with a touch, this was something you probably kind of had to learn on your own in this book. All right, looking at this one, even, odd, or neither again. What are we supposed to plug in? Negative x. All right. Excuse me. I've got the lovely summer cold. Since the first day of school. Isn't that nice? All right, so this is one of our trig identities. Last window, second column, second sign down. Everybody see it? Okay. When I have a negative on the inside, what happens? It goes positive, so it just goes away, right? So I get negative x cosine x. It wasn't affecting this negative, it was affecting that negative there. So what do you notice about the function? Is it the exact same function? Is it the negative of the function? So is it even, odd, or neither? Odd, good. Practice those ones, okay? You might be able to look. It says that there's 67 to 70, so there's some other ones there you could go practice, okay? All right, that's it, right? Okay, awesome. How much time? Oh, we've got time today. Okay, so here's what we're going to do. Get out a piece of paper, okay? Just random piece of paper, scratch paper. I'm going to keep